now. Hey everyone, welcome to the Weekly Space Hangout for Friday, October 23rd, he says, looking down at his computer, 2015. I'm Fraser, Cain, publisher of Universe Today, and we've got a bunch of great stories for you today. We will be talking about white dwarfs disintegrating planets, what's happening with New Horizons, supermassive black hole shredding a star, SpaceX setting a new launch schedule, opportunity updates, and Hubble spying Big Bang frontiers. And joining us this week, we've got a regular band of rogues, misfits. Kimberly Cartier. Hey, Kimberly.
Hello, everyone.
We've got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
We've got Nicole Gugliucci. Nicole.
Hello. Hello. Happy Friday. Oh, and happy Mole Day.
Is it Mole Day?
It's Mole Day, you guys. It's 10:23.
Avogadro's number?
Yeah, I have a mole. Okay.
Is that just after Back to the Future Day?
Yes, it is.
We got Paul Sutter. Hey, Paul.
Hey, how's it going?
Good. We got Ramin Skibba. Hey, Ramin.
Hey, Fraser. Good to be back.
And we've got a special guest this week, which is Matthew Golombek from NASA, JPL. Hey, Matthew, welcome to the show.
Hey, everybody. Hi.
All right. So since we have a very special guest, which we will be speaking with in a second, we're going to take the first 20 minutes or so and talk to Matthew, and then we'll get on to the other stories this week. So just want to remind you that this is a live show, so if you want to interact with us, you want to ask us some questions, go ahead and put your questions into the Q&A app, and I will be watching for them and passing along your questions to all of the guests that we have today. And just to show, I'm going to say hi to Richard Clark and Helge Bjorkog and Nancy Graziano and Jim Meeker and Billy Gordon and Marcel Bacher and Richard Strassel, Thomas Traneker, Ian Harris, Linda Sadek, Eric Briggs, too many now, Billy Corden, Kristen Dorfer, Sylvan Vespi, Elad Avron, Bill Kovacs, Douglas Crandall, and Michael Jobin, Guido Bibra, Beth Johnson, Tom Nathy. All right. Thanks to all of you for joining us, and a big thanks to Nancy Graziano, as always, for helping organize this week's guest, which I am super, super excited about. So let's get on with that first part with the guest. So, Matthew, welcome to the Weekly Space Hangout. For people who don't know who you are and what you do, can you give us a quick intro?
Hi everybody. So I'm the project scientist for the Mars Exploration Rover Opportunity, which is exploring Meridiani Planum Mars right now.
That's the one that's still fully operational, as opposed to Spirit, of course, was the one that went down a little while ago. How is Opportunity doing?
It's doing great. It's showing signs of old age, but that's okay. We all have that problem.
Well, when you think that the original mission was 3 months,
too, you know.
Yeah, well, the original mission was 90 days, right? So every day after that is a gift.
Yeah, and we're at, 11 now, so 11 years.
11 years of gifted days. And so where is Opportunity right now, and what is it working on?
So we're on the rim of Endeavour Crater, which is a 22-kilometer diameter impact crater that formed probably in the Noachian. That's the earliest phase of age on Mars, so probably over 3.7 billion years. And in the rim of the crater, we have strong evidence from orbital information, namely CRISM, that there are clays at this location. We're in what's called Marathon Valley, and the clays identified are iron magnesium smectites. And what's important about those on Earth and anywhere is that clays are weathering products that form from the interaction of other minerals with liquid water. And that's how you form clay. And in general, and this is the important part, they form under neutral pH conditions, so water that you could drink if you were there when these clays were forming. And thus, this is the only rover investigating the period on Mars when we think it may have been warm and wet at roughly the same time when life got started here on Earth. So you can ask the $24,000 question with your little rover on Mars, are we alone in the universe? will life form anywhere that liquid water is stable, or do you need some once in a gazillion chance occurrence by your friendly you-know-who?
And so, I mean, this isn't the first time that Opportunity, or at least the MER program, has turned up evidence that there has been water acting on the surface of Mars. You're racking up the independent lines of evidence now, right?
Yeah, and to just be clear, yes, and in fact, all the rovers on the surface have seen evidence of liquid water in one form or the other. The importance for this observation is that most of Opportunity's work has been in slightly younger rocks that were also deposited in water, but that water was like battery acid water, extremely acid, and so acid strong that there are things that actually live in that on the Earth, but we don't usually think of that as a good incubator for life, as opposed to the location we're at now, where it was neutral pH water, the kind you can drink and all your fish like to swim in. So we think this is a more habitable environment.
And so how long now do you think that this water was there on the surface of Mars? Like what time period was it probably there?
So we know it's probably older than 3.7, 3.8 billion years ago. So it's in the so-called Noachian period. How long the water interacted with the rocks is very poorly understood. And that, in fact, is one of the biggest questions on Mars right now, is we have strong evidence that liquid water existed on the surface. We see evidence for deltas. We see streams. We see valley networks in which water coursed across the surface. And the question is, how long was the water there? And usually you think that if the water was there for a longer period of time, it would be better for giving life a chance to get started. And we don't have a real strong knowledge about that. But the recent results from Curiosity on the other side of the planet indicates that water was there probably for hundreds of thousands to maybe even millions of years. And that's getting to the time scale where you think, maybe life has a chance to get going there.
How does that time frame overlap with life on Earth?
So the earliest evidence of life on Earth is, we have some chemical evidence at about 3.9, but the real true evidence that's undisputed is about 3.6. And people, geologists, think that life started on Earth as soon as the end of terminal bombardment, when the impactors were coming in so much that it effectively steam sterilized the Earth. So as soon as liquid water was stable on the Earth, it looks like life got going. And so, that's why going to Mars is so compelling. You can ask that same question in a scientific manner. No gods involved. How does life form and how prevalent would it be?
Right, and of course there's the idea that maybe life was moving back and forth between Earth and Mars with all of the
there have been suggestions. We certainly know that we have 20 samples of Mars on the Earth that have been blasted off the surface by meteorites, and you could posit that maybe things were nicer on Mars earlier on, and life started there and came to the Earth. So if we go back to Mars and we find life, heck, they're our cousins. We can move right in. As opposed to maybe there was a second Genesis on Mars. And that's even as compelling and interesting, I think.
It's like either answer is super compelling, right? That if there's no life on Mars, even though there's water for a long period of time, that's very interesting. If the life on Mars arose completely independently, that's really interesting. And if they're interconnected, that's incredibly interesting as well.
Yeah, absolutely.
Every possibility is interesting.
Yeah, and that's what makes the Mars exploration program so cool.
How do you feel about this clay? I think about like where I live on Vancouver Island. There's a lot of shale and silt and and it's an ancient ocean here, and tons of fossils in the the shale. Do you think this clay is a place that maybe some future mission could go and explore, maybe with a different set of instruments to kind of dig a little deeper?
So the location that we're at on the rim of the crater, we haven't yet found layered sedimentary rocks like the ones you've described. That well, yours are a little metamorphosed, but they started life as layered sedimentary rocks that were laid down in water, and that's super interesting and compelling. The rocks that we're investigating in the rim of the crater so far don't appear that. It looks like these are rocks that were breccias that were deposited when the crater formed, but the water has coursed through them and changed them. They've altered those rocks in a different way. So the likelihood of finding fossils in these rocks is not so good. And honestly, 90% of the sedimentary rocks on Earth don't have fossils that you can go and find. That's a kind of an unusual occurrence. So yeah, probably not much hope there. It would be very interesting, though, if you did see something that you thought was a fossil. How would you verify that? So there's a saying in science that extraordinary claims require extraordinary proof. Well, we got imagers and we got a little chemistry lab, and how do you determine if that fossil is in fact biogenic or some inorganic thing? And that would be very difficult. Certainly very difficult for opportunity. Curiosity might have a chance at it.
But future rovers are going to have more capability in this realm, right?
Yeah, we certainly hope. With time, the technology improves and the cost comes down, and we'd hope that there'd be advanced instruments. For something as important as this, it may be that we eventually need to get samples back from Mars to Earth to really be able to determine the answer to this. We may need the laboratories that fill up buildings here on Earth to really kind of do the detailed investigations that would allow us to get a definitive answer.
One of the problems with that is trying to, or considering the implications of bringing life back. I know that there are sort of international treaties that restrict the cleanliness, of the spacecraft that we send to Mars, and even more restrictive about anything that maybe we bring back from the red planet that could have some kind of living life form, organic stuff in it. So, what work do you think is going to need to be done over the next little while for those sample return missions to, be safe?
Yeah. So there's two halves to planetary protection. One is if you think life had a chance to get going on Mars, the last thing you want to do is bring Earth life to Mars and infect it. And then when you find life, you found what you brought. You found yourself. So that's not a great idea. So we have
tardigrades everywhere. What's that about? Yeah.
So we have planetary protection constraints on the forward part, which is that spacecraft that we send to the surface of Mars must be cleaned for our knowledge of the environment. Now, fortunately, most of the surface of Mars is not very conducive to life. The pressure is too low. We're below the triple point of water. Liquid water is generally not stable anywhere on the surface, and that's the one absolute requirement for life as we know it. So most of Mars is not very habitable. But you could imagine areas just down below the surface that have ice, that could even have water vapor. You could have thin films of water. And so you look at planetary protection as how clean do you need to make your spacecraft on Earth before you send it there? And all spacecraft are cleaned to a certain amount. They're built in clean rooms, and they have biobarriers that don't open up until they get into deep space. And then for bringing them back, now you have the issue of if there's something in that rock that could be deleterious to Earth life, you would definitely want to contain it. Now, scientists have a wide varying opinion about the latter, because if we've been getting chunks of Mars throughout geologic time, and that seems to be the case, we've already been infected by whatever Martian things there are, and we've already eaten it up and spit it out, and it's not something to worry about. On the other hand, there is some small concern, and so a sample return mission, and by the way, the first step of that sample return is the so-called 2020 rover, which will collect and cache samples for potentially eventually returning to Earth. we would need to bring them back into a clean room facility, and we would need to be sure that we break the chain between whatever was on Mars and whatever comes back to the Earth. That is, the samples are enclosed and packaged and put into something that's not going to break apart when it lands here on Earth, and then brought into this clean room facility and opened very carefully.
What about some kind of perhaps orbiting laboratory with astronaut scientists?
And that's
floating?
been suggested, and the trouble there is if you screw up, you've just wasted that asset. So it's been suggested, for example, to bring those samples back to the space station. Well, the cost of the space station is untold billions of dollars, and if you have an accident, you've just wasted that asset. And so in some ways, it's way better to bring it down on Earth and build something that can contain them.
Right, but it is less than the cost of the entire planet. But I see the case. But this is not the only mission. You know, you worked on the Opportunity rover. That's not the only mission. You've got another mission that you're going to be involved in coming up, right?
Yeah, so I'm a Martian, so all I do is work on Mars. In fact, since I think I'm the oldest Martian on the Earth, I'll define a Martian as someone who works 100% of their times on Mars, and I started that in 1993. So I'm in, 12 years or something? 22 years, wow. Okay, that tells you how old I am. That's bad. Okay, but anyway, several missions I'm working on right now. One is the InSight lander, which is a lander. It's not mobile, that carries a seismometer and a heat flow probe to Mars. It launches in March, and it gets there in September. And I'm working on the mission after that, the Mars 2020 rover, which is a reflight of Curiosity, only instead of the laboratory instruments, it's carrying a sample collection and caching system, where it actually collects those samples and bundles them up into little test tubes and leaves them on the surface for the next mission to come along and pick up and hopefully bring back to Earth. So it's an exciting time on Mars. We've had a renaissance of Mars exploration in the past 20 years. Eight or so missions, orbiters, landers, and the synergy between those observations have really allowed us to fine-tune our hypotheses and just learn so much more than we ever did in the early days.
Yeah, and as I said earlier, we're getting closer and closer to which of those three answers it really is, which is really exciting. So we've got some questions from the audience, and Ramin, I know you've got a question as well. So why don't you go ahead first, and then we'll take some questions from the audience.
Thanks. Yeah, Matthew, I was wondering, you said you have a seismometer. Does that mean you're going to be looking for earthquakes? I mean, are there earthquakes on Mars?
Yeah, we call them Marsquakes because they're on Mars. Yeah, so we're pretty confident that there's Marsquakes. So even though Mars doesn't have plate tectonics, which is the main generator of most earthquakes on Earth, it does have extremely large uncompensated loads and a lithosphere that's holding those up, and that's dynamic, and that's going to relax with time. As the lithosphere cooled, there would be Marsquakes that would result from that. And we know, given the number of moonquakes from the Apollo astronauts putting seismometers on Moon, that actually we think there should be way more Marsquakes than there are moonquakes, but not as many as earthquakes. And our guesses, our scientific estimates of the total moment release that would create Marsquakes suggest that there could be one teleseismic event, that is an event you'd hear anywhere on the surface of Mars, large enough to actually ring the planet once a month or so. So we're quite hopeful that we'll measure the internal structure of Mars. That's the main goal of this mission. But also, we have a seismometer. We should be able to hear impacts as well, and that would allow us to calibrate and measure the cratering rate at Mars, which is a completely interesting and very important point for us, because that's how we measure age on Mars without return samples. Yeah.
That's amazing that you would be listening for things smashing into Mars through the ground.
Yeah, we're pretty confident we can tell the difference between an internally generated double couple event, a Marsquake, versus a surface impact. the impulses are different, and the way they produce energy and so on is very, very different. So that's a very exciting possibility. And as you should know, or maybe you don't, but now I'll tell you, we do know that we can see dated impact craters on Mars, where we have a before image and an after image. So we're starting to measure that cratering rate on Mars using these before and after images. So we know those impacts are occurring, and now we'll have a seismometer to try to capture them as well.
That's cool.
All right, so let's get on to some of these questions. So the first one is, this comes from Tom Nathy. How hard would it be to make the soil of Mars usable, as in the Martian? So, you know, as we had it reminded to us this week, or last couple of weeks, that soil is filled with perchlorates. You know, what would it take to be able to grow potatoes in that soil?
So, I mean, it is possible. We don't know how prevalent the perchlorate is. That's been identified in a couple of places. Of course, growing anything would require you to make a greenhouse in which you boosted the surface pressure within that greenhouse to where liquid water is stable, right? Because right now on the surface you're below the triple point of water. So you're not going to you can't grow it just on the surface. You have two options. You create a special greenhouse, which is separate, or even more radical is you try to terraform Mars, where you make Mars more like the Earth. Now, there's ethical questions about that, right? We screwed up our own Earth. Now we're going to go screw up our neighboring planet.
Yeah, I always say that we're Venus-forming Earth right now.
Right. but you know, that is something you could consider, although hopefully that's in a while off.
Yeah. But the soil itself, depending on how prevalent the perchlorates are, you could, you know, assuming you had the pressure and you had organic material that you could add to it, you could theoretically grow stuff in that soil.
Yeah, that's the key. And, you know, some Earth folks, they don't even like us calling soil on Mars soil, because on Earth it includes organics, and so far we don't know that's the case on Mars. So I'm a planetary geologist. I'll forgive that. I'll call it soil on Mars. I'm a geologist. I'm not an aerologist, okay? Yeah. I study geology. It just happens to be on Mars. But no, the basic constituency of the soil, you know, it's got the same kind of general constituency as soils here on Earth. The composition's a little more basaltic, but other than that, you know, they grow things in Hawaii, no problem. So, yeah, nothing to stop you.
Awesome. So Elid Avron asks, seriously, if we did find some sort of evidence for life on Mars, how well could we tell it was a separate and discrete occurrence, or if it had the same origin as life on Earth? So what would it take to know if we're related? Or
key question, and it's difficult, but maybe not impossible. First of all, if it has a completely different structure from life here on Earth, then it would, you know, if it didn't have DNA and RNA and it was alive, well, that would be telltale, because all life on the Earth is based on DNA and RNA, and we know what that looks like, and we know how it's there. If it does have a basic building block like life on Earth, that is, it has DNA and RNA, then you have to look for something that's a little more subtle. One of the examples is the so-called racemization. It's all life on Earth is left-handed. The way in which the organic molecules connect is in one fashion only, and not the other. We have no life that's in the opposite-handedness. So if we went to Mars and we formed those organics and that DNA and RNA, and it was twisted the other way, that would indicate a second genesis, because we don't have any example of that here on Earth.
Right.
And there may be other ways, but it may be subtle and it may be very, very difficult. And you might actually need life on Mars now to do that, as opposed to what is actually fossilized and say, in the rock. That makes it even more difficult, because now you're preserving it, and it may not be preserved perfectly.
So this question comes from Richard Clark. Does NASA plan on having an orbiter with a ground-penetrating radar to send to Mars? And this has come up now with the mission that's going to be sent to Europa with a ground-penetrating radar to search for water under the ice. Any plans for that to go to Mars?
Yeah, we actually have two of them. One of them's in operation right now. One was called Marsis, that was looking down at kilometers depth, and there's a radar altimeter called a radar sounder, if you will, called Sharad, that's on the Mars Reconnaissance Orbiter that is orbiting Mars right now and getting information. And we've seen through the icy polar caps on Mars. That's allowed us to estimate the volume of ice on the poles, as well as see incredibly interesting internal layering in those polar deposits that tell you about how strong the lithosphere is to hold that up, and to give us some idea of how, what sort of time scale that those deposits have built up. So yeah, that's a very interesting activity going on right now.
Fantastic. All right, so I got one last question, and then we're going to let you go. So this comes from Alexander Howlett. How do you feel the scientific perspective of Mars has changed since you started working on Mars back in '93?
Oh, it's a world of difference. So back in 1993, when I started working on the Mars Pathfinder project, that was the first successful mission in 20 years to Mars. The previous ones were done in the 70s, and we had no new information, and we had no real knowledge about the mineralogy of Mars. We didn't know clay minerals existed. The evidence for a warm and wet ancient history was circumstantial but not very compelling. Each mission that's gone has raised the ante tremendously. We now know that the polar caps are made of ice. We know there's ground ice at the higher latitudes. We know there's evidence for clay minerals that form both at the surface as well as underneath the surface. We see evidence for water that rolled across the surface and formed deltas, standing bodies of water, and maybe even a northern ocean. So our knowledge of Mars has just revolutionized in the past 20 years, and it's been because we have had a whole variety of different missions that have gone and looked at different things, and we're comparing the data between the landers and the orbiters and this orbiter and that orbiter, and it's just been the best time if you work on Mars to be on Mars.
Fantastic. So we're going to let you go now, Matthew, but thank you so much for joining us on the Weekly Space Hangout today. It was great to hear the update. Opportunity is in our hearts. And as I said, every day that goes by, it's just another gift, a little more science. So
we treasure each day we operate that rover on Mars, because you don't know when it's going to be your last.
Yeah. All right. Well, thank you so much for joining us, and keep us posted.
Thanks very much, and yeah, invite me back.
All right. when you guys find life.
Oh, that may be a while.
Okay. All right then. Maybe something before. All right. Thanks a lot.
Hello.
All right, let's move on to some of the other stories that we've got today. So I'm going to randomly choose from the left on my screen, and that's you, Kimberly.
Okay.
What do you got for us?
All right, so fresh on the heels of this alien megastructure business with disintegrating planets and exocomets and whatever the heck is going on in that system, comes the story of a different disintegrating planet in a completely different part of the sky that was discovered also using Kepler, but instead of being around a hydrogen-burning star, like many of the other disintegrating planets have been, this one instead is around a white dwarf, which is a dead stellar remnant left over after something like the Sun finishes burning hydrogen and expends all of its outer layers of gas in a pretty nebula, and you're left with this really hot, really small white dwarf. And in the process of doing that, you would think that any planets in the system would just be blown away and there wouldn't be anything left to look at. But that's not the case with this system. Instead, we see what looks like remnants of what used to be a rocky planet. And we see all these fragments of planetary shards transiting in front of this white dwarf. which is pretty exciting for a few reasons. It means that perhaps after this star became a white dwarf, there was a planet left over that survived. And again, this is a process that we've never seen before, seeing planets around a white dwarf, even if they are just planetary shards. So in the entirety of the Kepler mission, we've only discovered 2 disintegrating planets. Both of them have been around regular hydrogen-burning stars like the Sun. And then K2, which is Kepler's follow-up mission, found 1, and then there's this white dwarf system. So there's 4 examples of disintegrating planets that we found, and this one is just as special as the rest of them.
Just as awful and apocalyptic as the others.
Also just as awful and apocalyptic as the others. But no aliens this time. We have a pretty good explanation as to what it is.
So based on what we've seen with this, what does that mean for us when our sun turns into a white dwarf?
Right. So our sun is going to go through the same thing one of these days, a few billion years from now. It's unclear exactly what that would mean for us. As the sun turns into a red giant and then eventually into a white dwarf, it's likely that the Earth will actually be engulfed by that red giant and will actually be destroyed well before it could suffer the same fate as these planetary shards around this white dwarf. But what it could mean is that something a little bit farther out might survive and might eventually undergo the same fate.
Awesome. I'm going to go quickly because we've got a ton of stories today. So let's move on. Morgan, let's talk about This Week in Musk.
Yeah, so if you remember back about 6 months ago, SpaceX had a launch accident during one of their launches in which a support strut in the second stage failed and it brought down the rocket. And of course, just like with Orbital 6 months before that, that triggered a long investigation into what went wrong and how to correct that and prevent it from happening while we move forward. Unlike Orbital, SpaceX has been able to conclude that investigation in just 6 months. And now have 2 Falcon 9 launches on the schedule for early December. And in addition to correcting this strut, they also were able to improve the efficiency of the engine that powers the Falcon 9. And this is actually a really big deal because it means they're going to be able to attempt to land on almost all of their launches. Previously, they could only really do this on the trips to the International Space Station because other types of launches simply required too much fuel to actually get the payload up to leave enough left behind to land the first stage. But with this new and improved engine, they're going to be able to attempt these landings on almost every one of their launches, and that promises to push forward the reusability project at a much faster pace.
So when will we see a rocket land on a barge?
So it could be as early December, but we just don't know.
Do you think they'll be successful?
They've been getting closer and closer, and it seemed like that that they were really on the brink of doing it. They'd gotten down to the barge, then they managed to hit the barge, then they managed to more or less stay upright before tipping over. And it seemed like they were on the cusp of success when they had their launch failure. And so I suspect that within a few more attempts, they'll be able to land on the barge, and once they can land on the barge, landing on solid, firm ground should be a much easier task.
Yeah, I mean, say that the barge has to be on water. Like, can they put the barge on land, and then that still counts?
I think probably it's got to be in water. Otherwise, it's just a pile of metal.
Well, I mean, the whole point of why they're doing the barge is that once they can prove that they land on the barge, then they'll be allowed to come back and land on the ground, back at the Kennedy Space Center. So it's really weird that they're sort of being forced to go through this much more complicated, difficult process of landing on a heaving, rocking target, and then once they can demonstrate they can do that, then they'll be allowed to land back at Kennedy Space Center. But I guess the point is to not land on the top of houses and things, right?
Or like the visitor center, so that I couldn't get any more free refills on my shuttle subby. That would be really bad.
Yeah, that would be a collector's item.
Yeah, I mean, they're trying something much more difficult than they need to do because the Air Force has already certified them for use on land as long as they can land within a 1 square mile landing pad. And the barge is certainly much smaller than 1 square mile, and they've hit it over and over again now. And so
Hard.
I think that this is imminent. Whether it
Yeah.
becomes cost effective is a different question.
But I mean, this goes to the big deeper issue, which is that, up until this point, SpaceX looked like they were completely disrupting the traditional, staid, boring, old launch industry with their maverick, can-do attitude and barge landings, and then they get the disaster, and then suddenly now United Launch Alliance is not looking like such a nobody ever got fired for going with IBM, and so nobody ever got fired going with ULA, and now SpaceX has got to make back up a lot of ground to go, no, we are the careful, cautious, risk-averse engineers that you like to associate yourself with.
Yeah, you don't get it both ways. You can't be fast and innovative and deliberate and completely safe. And we got to learn to find the balance that we're comfortable with in that respect.
Yeah, and you go the Russian way and you build the Soyuz and then you just launch the same spacecraft for 50 years, right? Well, let's move on. Next up, Nicole. Talk to me. We're talking about things getting shredded. Take it one order of magnitude.
Sure, we're going to shred up some stars now. So there was a story this week about a black hole shredding a star to pieces, and I added in my pre-show notes, but it's not just destroying things, it's creating things. It's probably creating a disk around that black hole. So this is a supermassive black hole. It's several million times the mass of the Sun in a galaxy called PGC 043234. It's about 290 million light years away. Sounds really big, but it's actually fairly close on the scale of galaxies. And this was observed with 3 different orbiting X-ray telescopes. Chandra, Swift, and XMM Newton took spectra, and it looked at the variability of this supermassive black hole. So as a supermassive black hole is pulling material into it from a star that it is shredding, it'll cause variability. It'll cause flashes in gamma rays and in X-rays. One thing that the Swift spacecraft is really good at doing is quickly picking up on these time variable X-ray events, and it's actually part of a SKY survey. This is a great acronym. So All Sky Automated Survey for Supernova. The acronym is ASSN, which totally to me reads like assassin, so I'm just calling this the Assassin Galaxy. It's actually like
I think they intended that.
Do they call it that? Okay, good. I haven't heard that one verbally.
I have the mug, and one of the... Paul, why don't you give a little background on that before we move on?
Yeah, so Assassin is this amazing project where they're trying to do searches like this really quickly and really cheaply with multiple instruments dotted kind of around the globe. I think their setup cost, if they want to set up a new installation in a new site, is very, very small, like on the order of tens of thousands of dollars, I think. To get all their gear so it can join in this automated search to go after supernova, and then also you get all this other cool stuff. And they have mugs and pens and stickers.
That sounds awesome.
Yeah, I've got one of their mugs, so I would grab it if I had it handy.
So yes, that's the optical light part that catches the optical light part. The X-ray part that they published on in Nature today. So this is, of course, artist's conception of this shredded bits of star being pulled in, and they actually got a look at this as it was very, very close to the black hole, and they could see these winds. I think that's what they mean by the blue stuff here, is this wind. Not all of the material always makes it into the black hole, and that's why you get these winds. You get in some instances you get jets. This could be what's helping to form the disk around that black hole. So it's a cool time variable source, X-ray, super high energy. They guys show you some nice spectra in there, and it's the destruction of a star, but possibly the building of a disk around that supermassive black hole.
Fantastic. Paul, I don't know what you wanted to talk about.
I don't either. I have a story. I can just start speaking it.
Why don't you just start talking, and then if it just goes horribly wrong, I'll cut you off.
Okay, so this will last 5 seconds. So the ESO, the Sphere mission, is a planet hunting mission, and they recently released this really cool image of an accretion disk around a star, but this accretion disk has some evidence for faint spiral arms. And I find this image and this study really interesting because in galaxies, we know lots of galaxies have spiral arms. We don't fully understand where these spiral arms come from. We know there's something related to density waves that have piled up on each other because of differential rotation. But the actual kind of gravitational perturbations that lead to those waves, we don't know if they're sourced kind of inside the galaxy and then are amplified, or if they come from things that orbit the galaxy or impact the galaxy and kind of set up these waves, like throwing rocks into a pond. And so anytime we can see spiral density waves in other places, in other contexts, it gives us some clues of what's going on. And we think the spiral arms in this little system might be set up, there might be some hidden planets inside there kind of mixing up the disk and setting up these density waves to create the spiral arms. And that's just cool.
This was one of those images where you look at it and I'm like, that must be an artist conception. Wait, no, that's an image? Like, it's that good.
Maybe an artist colored it.
No, I don't know.
I think the colors mean real things.
Yeah, it means a thing.
Yeah, right.
Pink. Well, I'll point out that
gradient or something.
Yeah, destroyed planets, and white means alien megastructures, right?
Oh, I hope not.
You're never going to be able to escape this.
I'm never going to escape it.
Dude, I don't even do exoplanets, and I've been getting questions from everybody on that.
Yeah,
me too.
Fun stuff.
Send them my way if you like.
I have been. I've been sending them a video of you talking about it on this show.
Oh, great. That's awesome.
That's perfect. I've been doing the same thing.
Yeah.
I'll point out that the same spiral waves that make those pretty pictures like that cause all of, or almost all, of the structure that you see in the rings of Saturn. And so the same physics works on scales that almost couldn't be more different.
That's really cool.
It's almost like they're laws of physics or something.
Almost like there are.
But it's,
what?
I mean, I think, when I first sort of learned about this, thanks to, I think, either Morgan or Pamela, that these structures, right, they're areas of density, but the density waves are kind of moving around, and that's separate from the actual particles themselves. It's not like when you see a galaxy and the whole thing is spinning, although it is, but those waves are actually density, and so the particles are sort of speeding up, or the stars are speeding up and falling into this density wave, and that's where you're seeing those arms.
It's like a water wave. When you're sitting on the beach in California, you're not getting water particles from China. You're just getting water particles from a foot away.
Yeah. All right, well, let's move on. Ramin, what do you got?
Sure. So there was some new results that came out from the Hubble telescope. I can show an image here if this screen share works. Let's see. Okay.
That's a good picture of Fraser from the Hubble Space Telescope.
Okay, here we go. So yeah, so there's these there's this Hubble program called Frontier Fields, and so it's basically Hubble focusing really intensely on one area, and so it's using what you might call these giant natural telescopes. So it's called gravitational lensing, where you have a really massive object like a clump of galaxies, and then particles of light, photons, get bent around it. And so it's sort of like a magnifying glass. So you have a telescope focusing on it, and you can see things further away than normal. And so they've detected hundreds of galaxies that are up to maybe 100 times fainter than and deeper than they normally would have with this. And so they found these super faint galaxies going back from the very, very early universe, around 600 million years into the beginning of the universe. So some of the very earliest galaxies that ever formed. And so this is pretty exciting that they were able to do this. And the other thing that's interesting is that these astronomers in this Frontier Fields program argue that these galaxies could have played an important role in ionizing, clearing away hydrogen gas in the early universe. Astronomers give it a funny name, reionization. But what it's doing is it's basically, so it is ionizing the gas, so it's heating up the gas and electrons fly off. It's turning the gas into plasma, basically. And so some people thought that maybe big galaxies could be playing a role in this, but then they say, well, there's not enough big galaxies. We need small galaxies too. And then these guys say, well, we've looked this far back. We see all these faint galaxies. This could be the answer to that problem. So it's pretty exciting.
And James Webb will take these kinds of observations to the next level, right?
Totally, yeah. So these are maybe like, so maybe James Webb could go back to the very, very early. So that would mean going up to 400 million years into the early universe. So James Webb would definitely tell even more.
And also the next generation of big radio telescopes, like the Square Kilometer Array, are looking for signals from this epoch. It's a major open question in cosmology of what the heck the universe was doing at this age.
That's right.
13 billion years ago.
I did not. I very carefully did not time my dissertation to finding that signal because I graduated 3 years ago and they're still working on it.
One like 4 pixels at a time, though, right? You just get with a radio telescope, you just get like just a couple of pixels, right?
No, it's an interferometer, dude. You get
All right.
megapixels.
All right. But so would you have been held back then, Nicole, if you'd be like waiting for that? You just would have had to stay in as a post-grad while waiting for the answer to trickle in?
Yeah. So I tied my dissertation to the building of the telescope and the work done, preliminary work done.
Right.
They're still working to get that signal. So yeah,
right.
it's really exciting.
It sounds like a wise move, though, right? You could have, like, if you had your papers, like, and the answer is, colon, and then you just had it sitting there, ... like sitting on your computer screen, just waiting
for some
year
people,
after year.
That's been their career through different stages. Mm-hmm. They're working on that problem through different stages.
Yeah. The challenge is that stuff in our own galaxy is literally 10,000 times brighter than the signal from the very early universe. And so trying to separate it out and dig it out is very, very challenging.
And it's also polarized. It's extra stupid.
Yeah. Polarization. So
Kimberly, you got an update on New Horizons?
Yes. So New Horizons, after having successfully flown by Pluto and given us so many wonderful images and so many wonderful things to come, has moved on and has successfully completed the first of 4 thruster fires to get it repointed now to its new target farther out in the Kuiper Belt. So that's 1 maneuver out of 4, and there should be 3 more coming, hopefully successfully, in the next 2 weeks or so. And they hope to arrive at this secondary target, whose name is MU69 for some reason. We'll figure out something more clever as we get closer, I'm sure. They hope to get there early 2019. So this secondary mission was approved, and the target was approved, and so now they've officially started moving their way onto the new target.
And the target is super small, right? It's going to be a very small object?
I remember seeing an image once where this target could fit into the Bay Area of Boston. So like the little alcove, I forget the exact word for it, but the Boston Bay Area. It could fit nice and neat in that little section of water. It's very tiny.
It's pretty amazing that they've seen an object that small and been able to sort of know that that's the next target. It's so far away.
Yeah. So, I mean, this target was discovered by Hubble too long ago, and it still is at the same stage, and what we know about it is what we knew about Pluto just from the Hubble images, not even that much, before New Horizons started taking images. So it's just a tiny little speck of light we noticed out in the Kuiper Belt, but it was one of the few targets that New Horizons was able to hit with its remaining fuel content and in a reasonable time frame.
Morgan, let's talk about budgets.
Okay. Well, every year since President Obama took office, back in 2009, we've pretty much seen the same sort of play come out for funding NASA. And that's that President Obama proposes a budget that cuts funding for planetary science in particular, and then Congress proposes a budget that increases or at least restores that amount of funding. And so it's kept the funding for planetary science basically at the same level since Mr. Obama took office. Now, another trend we've seen is that we're not actually passing budgets. Instead, we pass a law called a continuing resolution that just says, we'll fund at the same level as last year and worry about this again next week or next month or next year or never. Unfortunately, if you pass a continuing resolution, you can't spend more money than the president has asked for. And in this particular budget, President Obama asked to remove all funding for 2 long-running NASA planetary science missions. The Opportunity rover that we heard about at the beginning of the show, that's now been on Mars for 11 years, and the Lunar Reconnaissance Orbiter, which has been mapping the surface of the moon now for many years. And in total, they cost NASA about $78 million in the next fiscal year. And President Obama has removed both of those items from NASA's budget going forward. And so if, as expected, Congress passes a continuing resolution and the president signs it, that means that not necessarily that Spirit or that Opportunity and LRO will be cut, but NASA will be forced to spend $78 million fewer dollars than they did last year. And the easiest place to trim something like that off would be to cut these 2 long-running missions in line with the president's desires.
Is this like some form of brinksmanship here, where Obama is sort of getting Congress to actually pass an actual budget?
So, unfortunately for all of us, withholding money for Opportunity and the Lunar Reconnaissance Orbiter is not going to be enough to convince Congress to actually pass a budget. But it is kind of an amusing situation because in most areas of the budget, we see the president asking to spend more money to fund various programs, and Congress coming in and reducing the amount of funding that he's asked for. But in this case, the president has consistently attempted to reduce the spending on planetary science, and Congress has said, no, planetary science is important to our aims, and has furnished as much or more money than we had in the past.
Part of the crunch comes from the sequestration. Those limits are still in place, and so as long as they keep passing continuing resolutions, then those limits will NASA will be forced to do whatever they can with them.
Right. So in 1 year, back in 2011, we decided we're not going to pass a continuing resolution. We're actually going to pass a grown-up budget. And part of that was to get that deal done, we set hard limits on how much money could be spent domestically and on the military and on various other programs. And those were never intended to be permanent limits, at least not for many people. And yet now we've had them in place for several years, and of course inflation is raising the cost of everything, and yet we can't spend more money, and therefore in effective terms we're forced to spend less money in all areas, including NASA and space exploration.
So Nancy Graziano asks, how much of President Obama's request for budgetary cuts is his realization that no matter what he does, Congress will do the exact opposite of what he requests, thereby getting what he really would like to see. So he's like playing, he's trying to sort of do some kind of mind game with them.
Yeah, I think the president would probably take anything that he could get if he thought that it would get Congress to do something that he wanted to do.
We're already in fiscal year 2016, so it's they better get their act together.
Yeah, since September 30th, we're on borrowed time basically.
Right, and it won't be Obama's problem anymore.
And I guess this is more than just LRO and Opportunity. This is NASA is forced to try to plan long-term missions without any certainty that they'll have money tomorrow, much less next year. And this is a model that's very different than how ESA, the European Space Agency, plans their missions, because ESA receives money from the EU on a 5-year budget cycle. And so they know with certainty when a new budget is passed how much money they'll have for the next 5 years, which is about as much time as it takes to plan and execute a small mission like Opportunity. And so NASA, whilst attempting to undertake the largest space projects, is forced to do so with really no financial security beyond the next year.
Yeah. All right, so we're trying a new experiment with the Weekly Space Hangout, and for those of you who are actually sort of participate in the Weekly Space Hangout Crew community on Google+, the goal is to let the producers of the show, of course, the fans of the Weekly Space Hangout, be more involved in choosing the stories that we talk about, in sort of suggesting them and voting for the ones. So we've actually created a Trello board, and this is all just a prototype. Big thanks to Jim Meeker for working on this with me, where everyone who is a producer of the show, and that's anybody who is a member of the community, can suggest stories that go into the hopper, and then everybody gets to vote on the stories they want to see, and the ones that pop up to the top of the list, we will try to add those into the queue. And actually, Paul already dug one out of there, which you heard, which was about the cool swirling disc. We didn't even know about that. We wouldn't even have been covering that, and one of you recommended it, and a lot of you voted on it. So thanks, Paul, for jumping up. We've got a couple more stories, and I'm not sure. Again, we are literally now moving to the fly by the seat of our pants mode. One that people wanted to talk about is that Scott Kelly has broken the American record for days in space. And Morgan, I know you are not as impressed as perhaps anyone else.
Well, this is a remarkable achievement for Scott Kelly. He's now been in space for more than 390 days in his life. But in the grand scheme of time and space, he's still got a long way to go, and in fact will not catch up with the all-time record holder, which is a Russian named Gennady Padalka, who has spent more than twice as long, more than 800 days in space, departing last year for presumably the final time from the International Space Station. And in fact, Scott,
what's the record for a continuous stay?
I think 400 days, set by maybe somebody on Mir from the Soviet Union. In fact, Scott Kelly has yet to set the American record for continuous stay, which he will do before the end of his one-year mission in the coming months. But he has spent more time in space now than any other American in history.
And he's still a reasonably young man. He's got a lot of space flight ahead of him. He could take the record. And in fact, it might make sense to do another year-long mission and just see what happens to poor Scott Kelly as he goes back up again and sees if he can, what's going to happen to his body now.
Yeah, well, he has a twin brother staying back on Earth, and they're performing the same tests on both of them. So this really is sort of a form of human experimentation going on, where we've done as best we can to understand what effects are simply from the aging process versus what effects come from actual exposure to zero gravity and space food.
Awesome. All right. Well, Scott, we're going to need you to go back up. And so one other one. Kimberly, did you look at the most Earth-like worlds
Yes,
story?
I did. So the punchline here is that Earth has come to the party fashionably early in terms of habitable planets in the grand scheme of the universe. A recent study by scientists over at Space Telescope Science Institute has come up with a statistic saying that the majority of habitable planets that will be born in the entire history of the universe have yet to be born. And when you think about it, it's not such a surprising result, because our own Milky Way galaxy is less than 11 billion years old. Earth is only 4.5 billion years old, and the universe has about 100 trillion years to go before something happens. So in the grand scheme of things, there's plenty of star-forming material and planet-forming material to go through, and even though our own Milky Way is sort of slowing down in terms of star formation and planet formation, there are still plenty more galaxies to be born, plenty more stars to be born, and plenty more planets. And just based on the statistics that Kepler has been bringing in on how frequent habitable Earth-sized planets are, there are certain to be many billion more habitable planets to go. So Earth is just, leading the charge.
Well, there you go. We just wrapped up the Fermi paradox today. Perfect.
I was going to say that's one of the comments. What's one
They're
of the
just not here
solutions to
yet.
the Fermi paradox is that, well, maybe no one's here because we're the first. Oh.
We're the old ones.
We're the
So
old
that
ones.
research-
We're the ancient
Yes.
precursors.
Oh, that sucks.
So that research is actually by some galaxy experts, so Peter Baruzzi and Molly
yes.
Peoples. But they but they were able to sort of infer the star formation histories of galaxies. And so, like you said, it's they're able to see that there should be a lot more gas out there to make new stars. And so if we have billions of galaxies with billions of stars, and each one of those stars potentially has a planet, then there's a huge potential out there.
Right. So, I mean, the Kepler's telescope and all of their exoplanet studies have been focusing really on just the present of the Milky Way. But if you're looking in terms of the entire history of the universe over all of time and all of space, so very Doctor Who in that respect, there are plenty of more planets to come.
And so then the last one that we'll talk about just briefly is just an update on the ExoMars mission, which is going to be going in 2016.
Sure. So ExoMars is a joint Martian explorer between ESA, the European Space Agency, and Roscosmos, the Russian Space Agency. And ESA will be facilitating an orbiter that will look for the various small quantities of gas in Mars' atmosphere. We know most of it's carbon dioxide, but there's all sorts of other stuff in there as well, and they'll be studying that. And they're going to drop off a lander built by the Russians, which is battery-powered, will last only a short time on the surface. But if this works, it's going to be really big news because Russia, and previously the Soviet Union, has been trying to land on Mars for more than 50 years. And in fact, they've never successfully landed on Mars nor gone into orbit about it. And so if this works, then it'll be a big step both for them and for the exploration of Mars. And ESA, in charge of launching this mission, has in fact now committed to a launch date. Every 26 months you get a chance to launch to Mars. And the next slot coming up is March of 2016. NASA will be launching InSight, and on March 14th, a Russian rocket will launch ExoMars, hopefully all the way to the red planet.
Yeah, it's when we see those clusters of launches every time we get that alignment between Earth and Mars.
Isn't there an old Astronomy Cast episode where you guys go through the history of Martian spacecraft? It's really depressing.
It's super bleak because there's this huge period where the Russians sent mission after mission after mission to Mars, and they all just died. And then they took a break, and then sent the Phobos mission, and it died. And then the Grunt mission, it died.
Yes.
Yeah, and they call it the galactic ghoul, and that's this idea that there's some fearful, not that the Russians call this, but sort of people in the Mars spaceflight world, that there's this curse hanging over anyone trying to send a spacecraft to Mars, that Mars eats spacecraft for lunch. But now that's clearly been broken. The curse is lifted.
Since Spirit and Opportunity, NASA has an excellent track record of landing on Mars, but even for NASA, that wasn't always the case. And since then, in the 2000s, Russia has failed in a launch attempt to Mars as well.
Yeah. All right. Let's start to wrap things up. So, Kimberly, where can people find out more about you?
So, if you go to my website, which is kimberlycartier.org, you can learn all about me and all of the research that I am doing, and to learn more about me in the social aspect in terms of what I do for outreach, you can go to my Twitter handle, which is @AstroKimCartier.
Perfect. Morgan, where do people find out more?
Oh, man, I'm almost the same as Kimberly. You can follow me on Twitter @MorganRehnberg or visit my website, morganrehnberg.com.
Nicole.
Hi, I'm Noisy Astronomer. You can actually go to NicoleGugliucci.com and it'll take you to NoisyAstronomer.com. I did make sure to secure that. But yeah, I write very occasionally. I spend all of my time preparing lessons and grading this semester. First year prof, yay!
And if we wanted to take your class, where would we go?
You would come to St. Anselm College. I am teaching, next semester I'm teaching 2 astronomy courses. I'm very excited. It's a physics department, so I'm bringing all new astronomy stuff. It's very fun.
They're going to have a PhD astronomer teach a class on astronomy?
Yeah. Yes.
Nice.
The intro class, and then I'm also, intro to astronomy, which I'm teaching this semester as well, and which they hadn't taught here for 5 or 6 years. So all the students tried to jump in, and we're limited by the number of telescopes we have. And then I'm teaching Life Beyond Earth next semester, which is based off a course that I got to teach when I was a grad student at University of Virginia.
Wonderful.
Sounds like fun.
Aliens. Yeah.
Paul M. Sutter, where do we find out more?
You can find out more at PM Sutter, where the P stands for Paul. PMSutter.com, and you can also follow me on Twitter @PaulMattSutter.
And what if I wanted to perhaps contribute financially to the things that you do?
What a very intriguing question. You know, I've been thinking about this recently, and it's funny you asked. If you were to go to patreon.com/pmsutter, same as the website pmsutter.com, you can help me pay for my podcast and all that stuff I do.
So that address again is patreon.com/pmsutter.
Sutter. That is correct.
And there I can learn more about the Ask a Spaceman podcast.
Exactly.
God, you newbies, you're still gonna have to learn this, Paul. So don't make me drag it out of you every time. All right.
I like the drama of it.
He broke Brian. He can break you too.
Exactly. I broke Brian. I could break you too. All right. Ramin, where do people find out more?
Yeah, so you can find me on Twitter at Ramin Skibba, and my website is raminskibba.net, not .com. And all my writings are there, and I have a blog there too called Science Political. I'm actually working on updating the website, so some of the pages aren't done yet, but that's where you can find all my stuff. And I'm at the Science Communication Program at Santa Cruz right now.
Wonderful. That's awesome. How did you get that gig?
With a little help from you.
So once again, I'm Fraser Cain. You can follow me on the Twitters and on the Google Pluses, and of course, if you're watching this on YouTube and you haven't subscribed, why do you hate us? Subscribe. So thanks everyone for watching. Thanks a big special thanks to the folks at the WSH crew for helping organize some of the stories this week. I promise we're going to make this better, smoother, more organized over time. It's going to be a really powerful connection. And also a big thank you to everybody who went to iTunes and gave us a review. It's awesome. We got 15, 20 reviews. They look great. Yeah, it was wonderful, and it really means a lot to us that that you like the show, but also that you are willing to help us out and get the show out to more people in a bigger audience, and that means a lot to us. So, if you have time and you haven't already, go to iTunes, put in a review, and that means a ton to us. Okay, great. Well, let's wrap this up. Thanks, everyone. Thanks to our special guest. Thanks, and thank you. Goodbye.
Thank you.
Bye.
Bye.